Think about the last egg you ate. It probably looked so ordinary that you never questioned where it came from. But imagine this for a moment. What if I told you that the egg on your breakfast plate didn't exist 2 days ago? It wasn't sitting inside the hen, waiting to come out. It had to be built completely from scratch, layer by layer, in just over 24 hours. And somehow, a healthy hen repeats this incredible feat almost every single day. Now here's the first mystery. Building an egg isn't a simple job. It requires proteins, fats, water, minerals, vitamins, and one of the hardest natural materials a bird can produce, a calcium shell. If creating just one egg demands so much precision and energy, then why doesn't the hen need days or even weeks to recover? How can her body keep repeating the same complex process again and again without slowing down? Most people think they already know the answer. A rooster, they say. After all, no rooster, no eggs. It sounds perfectly logical. But what if everything you've believed about that is wrong? In reality, a hen can spend her entire life laying eggs without ever seeing a rooster. So if the rooster isn't responsible, then who is? More importantly, what tells the hen's body that it's time to start building the next egg? The answer doesn't begin with the shell. It doesn't even begin with the egg white. In fact, it doesn't begin with an egg at all. Hidden deep inside the hen's body is a tiny structure that quietly makes the first decision long before an egg exists. And once that decision is made, there's no turning back. A biological countdown begins, and within little more than a day, an entirely new egg will be ready. That tiny structure is the ovary. But here's another surprise. A female chick is born with 2 ovaries, yet as she grows, only the left ovary becomes fully functional. The right one almost completely stops developing. Scientists believe this adaptation helped wild birds stay lighter for flight while still allowing them to reproduce efficiently. One working ovary is all a healthy hen needs to begin one of nature's most remarkable production cycles. Inside that single ovary are not dozens, but thousands of microscopic follicles. Every one of them has the potential to become a future yolk. Yet they don't all grow together. Every day, the hen's hormones select just one candidate to continue developing. But here's the question that few people ever think to ask. Out of thousands of possibilities, how does the body know which yolk should be next? The answer is astonishingly precise. A carefully balanced network of hormones constantly monitors the ovary, choosing the follicle that has reached exactly the right stage of development. Once selected, that tiny follicle begins absorbing nutrients from the bloodstream, proteins, healthy fats, vitamins, minerals, and natural pigments. Slowly, almost invisibly, it grows into the golden yolk we recognize. But despite all of that work, there still isn't an egg. This is where the story becomes truly fascinating. At this point, if you could look inside the hen, you wouldn't find an egg with a soft shell waiting to harden. You wouldn't even find an egg without a shell. You would find only a yolk. No egg white. No membranes. No shell. Which raises an even bigger mystery. If only the yolk exists, where does everything else suddenly come from? The answer lies inside an extraordinary organ unlike anything found in mammals. It's an organ that works with the precision of an automated factory, adding each layer one after another without making a single mistake. But here's the twist. The moment this construction begins, something else quietly starts happening at the same time. The hen is already preparing the egg that will come after it. So how can one body build today's egg while simultaneously getting tomorrow's egg ready? That's exactly where the real story begins. The instant the yolk leaves the ovary, it enters a long, twisting organ called the oviduct. At first glance, it looks like nothing more than a narrow tube. But don't let its appearance fool you. This is one of the most sophisticated biological assembly lines in nature, where every section has only one job, every second matters, and every mistake could produce a defective egg. But how can a single organ build something so complex in just one day? The journey begins in the first section of the oviduct, and this is where one of the biggest misconceptions about eggs finally disappears. If a rooster has mated with the hen, fertilization can happen here. If he hasn't, nothing changes. The yolk continues moving exactly the same way. Think about that for a moment. The hen never asks whether the egg will become a chick. Her body keeps building the egg anyway. So the rooster doesn't start the process, he only changes what the finished egg is capable of becoming. As the yolk travels deeper into the oviduct, thousands of microscopic glands suddenly become active. They begin releasing a thick, crystal clear liquid around the yolk, one layer after another, until it is completely surrounded. This becomes the egg white, or albumin. But here's something most people never realize. The egg white wasn't designed mainly for us to eat. Its original purpose is to cushion the yolk, supply water and protein, and protect a growing embryo if the egg has been fertilized. Now watch what happens next, because it's easy to miss. While the egg white is being added, the yolk slowly rotates inside it. That gentle movement twists part of the albumin into two spiral cords called the chalazae. You've probably seen them before and assumed they were imperfections. In reality, they're one of the smartest parts of the entire design. They work like invisible suspension cables, keeping the yolk floating safely in the center even when the egg is moved, rolled, or turned. At this point, the egg already seems well protected. It has a nutrient-rich yolk, a thick shock-absorbing layer of egg white, and a natural system that keeps everything balanced. So why isn't the egg finished yet? Because without another layer of protection, harmful bacteria could still reach the inside long before the shell is formed. That's why the oviduct now wraps the developing egg in two delicate membranes that act as its first true security system. Then comes the longest and most demanding stage of the entire journey. The egg enters the shell gland, where it will remain for nearly 20 hours. During this time, the hen begins constructing something that seems almost impossible. She must build a shell that is strong enough to survive being laid, yet fragile enough for a tiny chick to break from the inside weeks later. How can one shell do both? The answer lies in millions of microscopic calcium crystals. Instead of forming one solid block, they interlock in an incredibly precise pattern, creating a structure that is both lightweight and remarkably strong. Engineers call this kind of design a balance between strength and flexibility. Nature perfected it millions of years before humans even understood the science behind it. But here's another twist. Even after the shell is finished, the egg still isn't ready to leave the hen's body. One mystery still remains. If building a single egg takes more than 24 hours, what tells the hen to begin the next one? Does she have an internal clock? Does her body simply wait until the previous egg is laid? Surprisingly, neither is completely true. The real trigger is something so ordinary that most people never imagine it could control an entire reproductive system: daylight. Every sunrise does far more than brighten a hen's surroundings. As light enters her eyes, it sends signals to the brain, triggering hormones that tell the ovary it's time to prepare the next yolk. In other words, the sun doesn't just mark the beginning of a new day, it quietly helps schedule the production of the next egg. But here's the strange part. If sunlight controls everything, why don't hens lay eggs at the exact same time every day? The answer lies in a difference of just a couple of hours. Building an egg usually takes between 24 and 26 hours, not exactly one day. That tiny delay pushes the laying time slightly later with each cycle. Eventually, the schedule shifts so much that the hen skips an entire day before starting over. That's why hens don't actually lay an egg every day, they lay one, almost, every day. But producing eggs this often comes at a price. Every shell requires a huge amount of calcium, along with proteins, water, vitamins, and energy. So here's another question. What happens when the hen doesn't get enough calcium from her food? Does egg production simply stop? Not immediately. Her body has an emergency backup system that few people know exists. Inside a laying hen is a special type of bone called medullary bone, which acts as a temporary calcium reserve. When the diet doesn't provide enough calcium, the body withdraws minerals from this reserve to finish building the shell. It's an extraordinary survival mechanism, but it also explains why poor nutrition can quickly lead to thinner shells, fewer eggs, and long-term health problems. Now here's the biggest twist of the entire story. Chickens weren't always capable of laying eggs this often. Their wild ancestor, the red jungle fowl, produced only a few eggs during the breeding season before stopping to incubate them. The almost daily egg-laying we see today isn't simply nature at work, it's also the result of thousands of years of selective breeding by humans. Generation after generation, people chose hens that naturally produced more eggs and bred them together. Slowly, those traits became stronger, creating the highly productive laying hens we know today. Yet even these remarkable birds can't keep going forever. As they age, or during molting when they replace their feathers, egg production naturally slows or temporarily stops because the body shifts its energy toward maintenance instead of reproduction. So the next time you hold an egg, remember what you're really looking at. It's not just breakfast. It's the result of more than a full day of perfectly coordinated biological engineering, guided by hormones, timed by daylight, powered by nutrients, refined by evolution, and shaped by thousands of years of human selection. What looks ordinary on the outside is actually one of the most efficient production systems ever created by nature. And perhaps that's the most fascinating part of all. The greatest scientific stories aren't always hidden in distant galaxies or deep beneath the ocean. Sometimes, they're waiting in the simplest places imaginable, quietly resting in the palm of your hand.